Hey, we're going to take a look at a few of your problems off of your final affirmation. And here's one that actually is off of your assignment that gave you problems. And so we're really going to concentrate on this one and try to help you out. Notice the given. DF, this line segment, is equal to GH, that line segment. So we know those two are congruent, or equal. We also know E to F is the same as G to E. We want to prove DE equals EH. Well, if we look at that, they have to be congruent, don't they? What you're going to do is you're going to write down using deductive reasoning and in a logical argument of why that's true. On this proof, you started it right. And then I think you gave up on some others. Even if you don't know anything, you can always write down the givens and at least you'll get some partial credit. So we're going to write down our givens. We're going to say DF equals GH. And that'll be given. And EF equals GE. That'll be given. If you just send that to the proof, you're going to get partial credit. Now, here's what we need to do. We need to prove DE equals GH. We need to get DE involved in this proof somehow. Well, if we take a look, the segment addition postulate, that's the one we concentrated on in one of your LTs. This part plus this part equals the whole thing. So that's what we're going to say. We're going to say, oh, DE plus EF equals, whoops, got ahead of myself, equals DF. You don't have to memorize this. It's a pull-down menu. This is the segment addition postulate. And then we're going to do the same thing for what equals the whole length GH. We want to get EH involved in here somehow. So we're going to say, oh, GE plus EH, that equals to GH. Part plus part equals whole. Same reason, segment addition postulate. Now, remember in our given, we're told DF equals GH. So what I'm going to do, instead of writing DF, I'm going to what equals DF, which is DE plus EF. So DE plus EF equals, well, instead of writing GH, I'm going to say GE plus EH. When you write something instead of something else, that's called substitution. Let's look at our second given now. Our second given, I'm going to use a different color here so you can see it, is EF equals GE. So I think what I'm going to do in this statement, instead of writing EF, I'm going to write what equals EF, which is GE. I'm going to write the rest of the problem exactly the same. DE plus GE equals GE plus EH. And that's substitution again. Now notice, whoops, I said one thing and I wrote something different. I'm sorry about that. That's GE. There we go. Now notice, on both sides of the equal sign, that's GE. We can use algebra and we can subtract GE from both sides. Well, if you subtract GE from both sides, let me write that down here. So I'm going to minus GE I'm going to minus GE. So what's left? Well, what's left is DE equals EH, which you were trying to prove. Notice, that's what we're trying to prove. So you're done with the proof. Why did we do that? Well, we used algebra. On Alex, that's called addition and subtraction properties. That is, you're subtracting the same thing from both sides. Most of the proofs on this test follow this formula, if you want to call it, this logic, and that's what you're going to have to do, and that's what you have to do on your assignment. So before you do this, before I open the test again, I want you to go back and do that assignment. Now on the next one, it was kind of frustrating here because part of it is right. Let's talk about the part that's right. You know that this angle 63 degrees is an, whoops, I wanted the arc there, is an alternate exterior angle to 5x minus 112. So that's the part you had right. You said, hey, 5x minus 112 equals 63. What I did see is I did not see, oh, by the way, y is correct. So if this is if this is 63 degrees, then this is 117 degrees, which is correct. You had that part right. But you didn't finish the problem. 5x minus 112, I don't know how you got your answer for x. Well, let's go through that. This is just algebra. So to solve for x, first we add 112 to both sides because you're subtracting 112. So we add 112 to both sides. So then we bring down the 5x equals, let me see, you get 175, don't you? Well then, we divide both sides by 5. 175 divided by 5. Well, 5 goes into 17 3 times, with 2 left over. So then 5 goes into 25 5 times, so you get 35. I don't know if it's not necessarily a degree because you're just finding x. So you found y correct, you just need to finish the problem to find x. Now this problem is very similar to the first problem we did. Only the difference is its angles, which you're going to notice it kind of follows the same pattern. We're told in the given angle AXC is congruent to angle DYF. We're also told angle 1 is congruent to angle 2. Do you see the pattern there? So let's start this. Statement reason. The only difference between this one and the first problem is we're dealing with angles. Otherwise, it's the same thing. So we'll start with our two givens. We know the measure of angle AXC equals the measure of angle DYF. Given. We know the measure of angle 1 equals the measure of angle 2. Given. Yeah, that part you should just get automatically. So you get some partial credit. Now, let's use the fact we want to get angle 3 involved. Well, I know angle 1 plus angle 3 equals angle AXC. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle AXC. Why? Instead of calling it segment addition, it's angle addition property. And we'll do the same thing for angle 2 and 4. The measure of angle 2 plus the measure of angle 4 equals the measure of angle DYF. Reason? Angle addition property. Now we're going to use the fact that we know AXC equals DYF. So instead of writing AXC, I'm going to write angle 1 plus angle 3. Instead of angle DYF, I'm going to say 2 plus 4. So we're going to say, oh, the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. Why? Substitution, because you're replacing one thing with another. Now let's look at our second given. Our second given tells us, oh, 1 equals 2. So instead of writing angle 1, I'm going to write angle 2. The rest of the proof stays the same. The measure of angle 2 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. Reason? When you write something instead of something else, that's called substitution. Then, notice there is angle 2 on both sides now, isn't there? So we can subtract that off, and we're left with what you want to prove. The measure of angle 3 equals the measure of angle 4. Reason? Addition and subtraction properties, because we can subtract angle 2 from both sides. And you're done. That's all you had to do in that question. So it's very similar to the question with segments. You're going to see on your test they're very, very similar. You just have to do the got to do the logic. Now on this one, this is the same thing we did on step 1, except they gave us the statements. We have to supply the reasons. Now you had some of the reasons right and some of the reasons incorrect. This one is kind of confusing because they don't start with a given, do they? So here's what I want to tell you. Go in the proof and find where you see QS equals TV. That's step 3. So you should never get this one wrong because it's given. Go in the proof and find RS equals TU. That's given. Now, we've got the givens taken care of. Let's look at the others. Why does QS equal QR plus RS? Well, QR plus RS, that's segment addition. And we'll do the same thing for TV equals TU plus UV. That's segment addition. Now, after a given, we know QS equals TV. So instead of writing QS, we can write QR plus RS. Instead of writing TV, we can write TU plus UV. That's step 4 then. When you write something instead of something else, that's substitution. And then we're given RS equals TU. So it looks like instead of writing RS, they put in TU. Notice what changes. Well, that is substitution again. Now notice there's TU on both sides, so you can subtract that out. So there's your addition and subtraction properties. Now in this one, when you did the proof, you weren't too far off. I'm going to explain what you did wrong and try to help you out. It was a little bit longer than what you have, but you started off with the given, which is correct. We're told DC is parallel to EG. I'm going to put the arrowhead like we had on the seminar. So DC is parallel to EG. Given. And then we have angle 1 is congruent to angle 6. given. Now you said DE is parallel to HF because 1 and 6 are consecutive interior angles. Here's the problem with that. Angle 1 and angle 6 aren't connected by a transversal. So we got a problem there. So here's what we're going to do. We're going to use the fact we have angle 1, but let's use the lines that are connected by a transversal, or the angles that are connected by a transversal. If you want to make things a little bit easier, you might want to extend this line out here so you can see where the transversal is. Extend this line out here. Now notice, we have angle 1. If we look over here with this parallel line, well, there's only one angle one could be congruent to. Angle 1 is congruent to angle 2. And why do you know that? Because they're alternate interior angles. So we say if the lines are parallel. You always start the if part with something you know. So we know these lines are parallel. So we're going to say if the lines are parallel, I'm going to abbreviate here, then 1 and 2 are alternate interior angles. So we have the alternate interior angles are congruent. And once again, you don't have to have this memorized. It's a pull-down menu. It's kind of like multiple choice. Now, granted, it's a lot of choices, but that's what it is. I'm going to mark down here. 1 is congruent to 2. Oh, I'm going to mark down my given 2. 1 is congruent to 6. Well, look at that. If 1 is congruent to 2 and 1 is congruent to 6, notice 2 and 6 are congruent, aren't they? We can see that here. 1 is the same as angle 6, and 1 is the same as angle 2, so that means angle 6 has to be congruent to angle 2. That's the everything is congruent property, which is called transitive. Now look at your picture. What kind of angles are 2 and 6? Well, they're corresponding, and we know they're equal, aren't we? So that tells me if the corresponding angles are equal, I've got my proof. That makes these two lines, my D looks sick, I'm going to rewrite that. DE is parallel to HF. F. Sorry about that. There we go. Extra line there. Now, what do we say there? Now, this time, we're told the angles are congruent. So you're going to pick the second one in that choice that says, if the corresponding angles are congruent, then the lines are parallel. I know to pick that one because the then part always goes with your statement. So up here, we're saying the angles are congruent, so then the alternate interior angles are congruent. Here I'm saying the lines are parallel, so then the lines are parallel. We know the corresponding angles are congruent from the previous line. So that's how you tell the difference between those two. Now this is one I really needed to see your work, because you were mostly right on this question, but we had some problems here. So let's start with line 1. To find the slope from algebra and from your seminar, y2 minus y1 over x2 minus x1. So I'm going to find the slope of line 1. So I'm going to go in here and write it up here. So here's x and y, x and y. So now, to find the slope of line 1, we're going to say negative 8 minus 4, and you could have said 4 minus negative 8. That part doesn't matter. The order doesn't matter. But whatever you have in the order for the numerator, you have in the order for the denominator. So then you have negative 5 minus a negative 1. So negative 8 minus 4 is negative 12. When you subtract a negative, we end up adding. So negative 5 plus 1 is negative 4. A negative divided by a negative is a positive. For the slope of line 1 was 3. Now that was the one you had incorrect. I think you had negative 3 or negative 1/3 or something like that. Line 2, you had correct. I'm just going to write that work up here because you had that correct. I'm going to say 7 minus 1 over 2 minus 0. So 7 minus 1 is 6. 2 minus 0 is 2. That is also 3. I'll do the same thing for line 3, which you had correct. Negative 7 minus a negative 3 over 6 minus a negative 6. So it's negative 7 plus 3 is negative 4. 6 plus 6 is 12. You get negative 1/3. Now, the second part B is where we had some mistakes. Lines are parallel if the slopes are equal. So, parallel means equal slopes. Lines are perpendicular should mean the slopes are opposite reciprocals. So they're opposite signs and they're flipped. So if we look at line 1 and 2, notice they're the same. Since they're the same, they're parallel. Lines 1 and 3, notice negative 1/3 is opposite and flipped, so line 1 and 3 are perpendicular. Lines 2 and 3, same thing. They're opposite and they're flipped, so they're perpendicular. That's what we should have done for that one. And what happened is you had this first slope wrong, but even with that slope wrong, these didn't match what you had. And that's it. So now what I want you to do is I want you to finish those assignments. If you can't get those assignments right, then we need to Zoom so we can explain what's going on and have some feedback back and forth about what's confusing you. After you get those assignments correct, send me an email if you don't need any help, and then I'll reopen this and have you redo it.